Hi dears, welcome to Brilliant Katha JEE Mantra Series Chemistry Part Test 4 recap video. In this session, we are mainly going to revise the chapters aldehyde, ketone, carboxylic acid and alcohol, phenol, ethers. That are two important chapters as well as longest organic chapters. Okay, so see, two chapters we are going to discuss: alcohol, phenol, ethers as well as aldehyde, ketone, carboxylic acid. So let's look about the important topics from the chapter alcohol, phenols and ethers. Okay, so here in alcohols, phenols, ethers, first of all you have to remember about the preparation of alcohols. How we can prepare alcohols. From alkene we usually used to prepare, that is either by acid catalyzed hydration or hydroboration oxidation reaction. Okay, from carbonyl compounds, that means aldehyde, ketone also we can prepare, that is either by reduction or by using Grignard reagent. As well as especially we have to remember, okay, especially for the entrance exam point of view, we have to focus what? Preparation of phenols, that is from haloarenes or else from benzene sulfonic acid or else from diazonium salt, okay, or else from cumene, that is actually the manufacture of phenol, that is also very important. And from here, the next topic we have to remember is chemical properties of alcohols and phenols. Okay, you don't want to worry, we will go one by one. Okay, see, here in chemical properties, first of all, we have to remember acidity of alcohol and phenols. Okay, alcohols as well as phenols are acidic because of that OH bond, polarity of OH bond. They can donate that H plus, so that's why they are areneous acids. Okay, so next one, esterification reaction. That also basic idea, you know, acid, carboxylic acid as well as alcohol in presence of an acidic medium, they will give what? Fruity smell compounds, they are called esters. Okay, about that we have to learn. Then reaction with hydrogen halide, that is very important. That's very, very important. Okay, Lucas test. And reaction with PX3, I mean phosphorus trihalides, then dehydration reaction, then reaction with the copper catalyst, okay, copper catalyst, and then again you can see reaction of phenols. Reaction of phenols are very important, such as electrophilic substitution reaction as well as Kolb's reaction and Reimer-Taimer reaction. Okay, then in the case of ether, once we come to ether, about ether we have to remember Williamson synthesis as well as reaction of ether with hydrogen halide, especially with hydrogen iodide, and electrophilic substitution reaction. This many concepts if you go through means then we already went through what? All the ideas of what? The alcohols, phenols, ethers. Okay, you have to go through it. You have to go through it before, whenever you are solving the problems, whenever you are not getting means, you have to go back to the theory and you have to learn like that. Okay, don't spend more time to learn theory and don't think like that after learning theory we will do complete problems, not possible. Okay, you just go through the questions. You already learned the theories. Okay, for that only we are making the recap video. So after that, okay, once you are solving the problems, that time if you are not getting means you just go through it. Okay, you just go through the theory, that's all. Okay, so see, listen, once we are looking here, you can see preparation of alcohols. Preparation of alcohol, the first preparation is acid catalyzed hydration. Okay, that is from alkene. You are having one alkene, you can see one alkene, that acid catalyzed hydration. That means you are adding water molecule, okay, in presence of an acid. Okay, it is purely taking place in accordance to Markovnikov rule. That means carbocation mechanism is taking place. You are having water means H plus as well as OH minus is there. So what is Markovnikov rule? Simply you can remember rich become richer. Okay, rich become richer. Rich become richer. So what is rich become richer? Who is rich here? The more number of hydrogen containing carbon in that alkene, that is what is, I mean in that alkene means in that unsaturation, okay, unsaturated carbon, here it is more rich in hydrogen, towards there only hydrogen will go and here OH minus will go. So you can see CH3, CHOH, CH3. Here rearrangement is possible, carbocation, more stable carbocation, that rearrangement is possible. Okay, that idea you have to keep. So that is what is called what? Acid catalyzed hydration reaction. Okay guys, yeah. Next one, second one, by hydroboration oxidation reaction. Here the same alkene we are having, we are treating with the diborane, then in aqueous and H2O2 hydrogen peroxide, and in alkaline medium they will give you alcohol, but here the addition of water molecule takes place opposite to that of Markovnikov rule. Okay, opposite to that of Markovnikov rule. Means we are having H plus as well as we are having OH minus. Markovnikov rule means H will go along with CH2, but Here opposite. If it is B2H6, H2O, H2O2, OH minus means that is orthoboration. See, hydroboration, oxidation reaction means this H plus will go along with the CH and OH will go and attach here. You can see CH3, CH2, CH2, OH. Okay. So that's the product. So opposite to Marconic of addition. Again, here one more thing. Third one, that is actually oxymercuration, demercuration. Okay. Oxymercuration, demercuration. So mercuric acetate and tetrahydrofuran in presence of water, once you are treating, substitution will take place. Here you can see addition will take place. Okay, this group will be added. Then after that you are reducing that one in presence of an alkaline medium. So it is actually simply you are having one alkene. You are having one alkene RCH double bond CH2. Okay, here actually what is happening is addition of water molecule accordance to Markovnikov rule. That means what will happen? See what will happen? Here O will go and attach, H will go and attach, here OH will go and attach. So you will get RCHOH CH3. But there is no rearrangement. There is no rearrangement here. So 3 reactions, same kind, addition of water only. But first one, acid catalyzed hydrolysis or hydration means addition of water with rearrangement. Second one, oxymercuration, that time anti-Marconic of addition. Here also, here what? Here oxymercuration, demercuration. Before that we learned what? I'm sorry, hydroboration, oxidation, that is anti-Marconic of. Here in oxymercuration, demercuration, what? This actually without any rearrangement, Marconic of addition. Keep it in mind, okay? Yeah. Next again from carbonyl compound. Carbonyl compounds means aldehyde or ketone. If it is an aldehyde, okay, if you are reducing that one in presence of lithium aluminum hydride, you will get primary alcohol. And if it is a ketone, and you are reducing with lithium aluminum hydride, you will get what? Secondary alcohol. Reduction means simply addition of what? Hydrogen, that you can do with what? More stronger reducing agent like lithium aluminum hydride. So you will get what? Secondary alcohol if it is a ketone. If it is a aldehyde means what you will get? Primary alcohol. That idea you know? Okay. Yeah. Next one from Grignard reagent. You are having carbonyl compounds. Once you are treating with RMgX, you know, this oxygen will take the electron towards it. So oxygen will become negative. Oxygen will be getting which charge? Negative charge. This carbon will be getting positive charge. After that you learn the idea in this RMgX, Grignard reagent, always the bond will break here. RMg, that bond only covalent bond. R will get negative charge, Mg will get positive charge. That Mgx will go and attach with O, R will go and attach with C. That only I wrote here. After that you are conducting acid hydrolysis. So that time here it will break, here which one will go and attach? OH, here H will go and attach. So you will get an alcohol. If you are taking formaldehyde if you are taking, and if you are treating with a Grignard reagent and you are hydrolyzing, you will get primary alcohol. Any other aldehyde you are taking other than formaldehyde, any other aldehyde you are taking, you are treating with the Grignard reagent and hydrolyzing, you will get what? Secondary alcohol. Any ketone if you are taking and if you are treating with the Grignard reagent and hydrolyzing, you will get tertiary alcohol. That idea is very important. Formaldehyde only will give what? Primary alcohol. Any other aldehyde will give what? Secondary alcohol, and ketone will give what? Tertiary alcohol. I know that you are recollecting the ideas, correct? You are recollecting the concepts, right? X or no? Yeah. Okay. I can see your face. Okay, I can read your mind. Okay. Yeah. See, listen. Next one, preparation of alcohols. This one we already learned. Dow's process in haloalkanes, haloarenes. We learned nucleophilic substitution in haloarene is not possible. But according to Dow, what he did, you are having chlorobenzene, but drastic condition, 300 atm, 623 Kelvin. We are using NaOH and we are in acidic medium. What will happen? Here instead of this Cl, initially it will become ONA will come. Then in acidic medium that will become phenol. That is what is called a Dow's process. And in second one from benzene sulfonic acid. Benzene sulfonic acid, how we usually used to prepare. Benzene is there. To that we will treat oleum. Oleum means H2S2O7. Okay. Once you are treating, you will get benzene sulfonic acid. You will get that benzene sulfonic acid. We will treat with alkali NaOH, that will give you ONA. In sodium phenoxide you will get that, we will acidify, we will get phenol. Okay, NaOH and H+, you will get what? Phenol. That's another method. Third method is diazonium salt. That also we learned in amine chapter, that we already in the part test 3 recap video we already discussed about what? Diazonium salt, that idea we learned. So actually we are having aniline. That aniline we are treating with what? NaNO2 and HCl. Okay, that means nitrous acid at 0 degrees Celsius to 5 degrees Celsius. Okay, they will give you benzene diazonium salt, which on warm water is only at 5 degrees Celsius. If you are heating to 10 degrees Celsius, means that benzene diazonium salt will be converted to what? This is unstable. This diazonium salt, diazonium chloride is unstable. Okay, diazonium chloride is unstable. So whenever you are heating, I mean that is stable only at 5 degrees Celsius. Okay, up to 5 degrees Celsius. Once you are heating that one, means that will become phenol. Okay, this also replacement of that nitrogen. Nitrogen is removing. Okay, then you are getting what? Phenol. That's also very important idea. You have to keep that idea in mind. Okay, next one is from cumin. This is the manufacture of phenol. Large amount, industrial scale, we are preparing phenol from where? Cumin. Cumin is nothing, you can see. This is isopropyl benzene, like this. See, this benzene is there. Here CH, here CH3, and here CH3 is there. This is what is called what? Cumin. Then you are oxidizing that one, so they will form a peroxide. After that, you are acid hydrolyzing, you are doing that time what you are getting? Phenol, and along with that acetone will be there. So this is the important method. It's a very important method because it's the manufacture of what? Manufacture of phenol. That idea also you have to keep it in mind. Okay. Next again, we have to learn about what? Acidity of alcohols and phenols. Acidity of alcohols and phenols. We know the idea. Acidic character of alcohols as well as phenols is mainly due to what? Polar nature of OH bond. In your alcohol, that OH bond is there. From that OH bond, this OH bond is polar because oxygen is electron negative. That will get a delta negative, it will get a delta positive once they are attracting the electron. If this become more polar, means this H can be easily removable. Okay, this H can be easily removable. That's the idea. So here an electron releasing group increases the electron density on oxygen. So see here, this R, alkyl group is a electron donating group that will donate electron because of plus I effect. Automatically electron density on this oxygen will increase. Automatically this polarity will decrease, meaning this OH bond become less polar, that become less acidic. That's why, see, that's why ROH is there. Okay, R2OH. So that means we can write like this. See, we can write like this. O, and it is connecting with the CRR. Okay, RCR. So here OH is there. This is secondary alcohol and tertiary alcohol. This one CRROH. Okay, in this case, once you are looking, see here, this only one alkyl group is donating electron to oxygen. Here 2 alkyl group is donating electron to oxygen. Here 3 alkyl group is donating electron to oxygen. So in this case, this OH bond is very less polar. Automatically this H is not removable easily. OH bond is not removable easily. Okay, so this one, more than that, this H plus we can take it. This one easily we can take it. That's why primary alcohols are more acidic than secondary alcohol, than tertiary alcohol. Similarly, if there are electron withdrawing group is there, means that will become more polar. Easily that H plus is removable, more acidic. Similarly, another idea, phenol is more acidic than alcohol because whenever that H plus is going, phenoxide ion is forming. This phenoxide ion is more resonance stabilized. That's why phenol always try to, even than phenoxide ion is more stable than phenol. So that's why always phenol will try to lose that H plus and form what? Phenoxide ion. Always they will try to form what? That phenoxide ion. See, always they will try to get that phenoxide ion because in phenoxide ion, the negative charge is in this what? This oxygen, electronegative oxygen. Okay, so that's why that is more stable. Okay, more resonance stability is for phenoxide ion than phenol. That idea you know. So that's why they are more acidic. In phenol itself, if there any electron withdrawing group is there, means its acidity will increase. If there any electron donating group like CH3 and all is there, means CH3O like that because of resonance. So their acidity will what? Decrease. That idea you have to keep it in mind. Next again, once we are going to esterification. Esterification means we are having a carboxylic acid, RC double bond OOH, okay, as well as an alcohol, as well as we are having what? An alcohol, HOR dash, okay. In acidic medium, what will happen? From alcohol, this H plus, and from acid, carboxylic acid, OH, water will be eliminated. Then what is remaining there? R, C double bond O. Then you can see O, R dash will be there plus H2O. Don't confuse that. Don't confuse like what? From acid, OH is removing. From alcohol, H is removing. Okay. Don't take it in reverse way. This is according to Fischer esterification mechanism we learned in the classes. Okay. If you have doubt means, you can check the description box. It will be there. Okay. Don't worry. So that is what is the esterification reaction. Okay. See, next again, the Lucas test. Lucas test is to distinguish tertiary, secondary, primary alcohol. Okay. Actually, we learned this idea in where? In the preparation of haloalkane. Here, if we are taking a tertiary alcohol and Lucas reagent is concentrated HCl and anhydrous ZnCl2. Concentrated HCl and anhydrous ZnCl2 is called what? Lucas reagent. Once you are treating with the Lucas reagent with the tertiary alcohol, it will give immediate turbidity. Tertiary alcohol means this one. R, C, R. Okay, R. Here OH is there. Once you are treating with the concentrated HCl and anhydrous ZnCl2, this OH will go along with this H plus. Then it will be forming what? RCR. So this is a tertiary carbocation you will get. That is more stable. So easily this OH bond will removable. Okay. CO bond is breakable easily. And if it is secondary alcohol means you can see here H, here OH. If it is removing, OH is removing means you will get a secondary carbocation. If it is a primary alcohol means, see, if it is a primary alcohol means you will get what? You will get what? Once this OH is removing, you will get what? A primary carbocation. So tertiary carbocation is more stable. Then after OH is removing, there Cl minus will come and attach. Okay. So that's a nucleophilic substitution reaction. So here you can see, here you can understand easily like what? More stable the carbocation, more easily you will get haloalkane. You are going to get haloalkane. So if it is a tertiary alcohol means you are getting tertiary carbocation more stable. So that's why easily they will give turbidity. That haloalkane, okay. Instead of this OH, here Cl is coming and attaching means that is turbidity. Haloalkane gives the turbidity. So tertiary haloalkane will give immediate turbidity. And if it is secondary alcohol means it will give turbidity within 5 minutes. And if it is tertiary alcohol means it won't give turbidity easily. But once you are heating, you will get the turbidity. Okay. Yeah, because of carbocation mechanism. You know the idea. Anyhow, remember that idea. Again, reaction with the copper, especially reaction with hot copper. Once you are treating, you are having primary alcohol. If you are taking primary alcohol, if you are treating with the hot copper, it's nothing. Here actually happening is oxidation. Oxidation is taking place. Primary alcohol will give you what? Aldehyde. It will give you aldehyde. And if it is secondary alcohol, in presence of hot copper, it will give you ketone. And if it is tertiary alcohol, hot copper, not oxidation, elimination will take place, or dehydrohalogenation will take place. Okay, that means from here OH, from here H will go, in between that double bond will come, you will get what? Alkene. You will get alkene. That idea you have to keep it in mind. Primary alcohol means hot copper, you will get aldehyde. Secondary alcohol will give you what? Ketone. And tertiary alcohol will give you what? An alkene, because of here dehydration, not dehydrohalogenation, dehydration. From here OH, from here H, dehydration will take place. Okay. See, next one again, electrophilic substitution reaction. Phenol, you know the phenol. In phenol, you know that OH group is electron donating group. Because of plus resonance, that phenolic benzene become more electron rich. So electrophile can easily come and attack on that one. Okay, so electrophilic substitution is easily possible in phenol. If you are treating with the concentrated nitric acid, NO2 plus group will come, that will go and attach where and all it can come and attach ortho portion as well as para portion at a time. Then you will get 2,4,6 trinitrophenol, or else it is called picric acid. Okay, it is used for making explosive and all. That is picric acid. Okay, picric acid, 2,4,6 trinitrophenol. And if you are taking dilute nitric acid at 298 Kelvin at room temperature, you will get a mixture of orthonitrophenol and paranitrophenol. Always paranitrophenol will be major product than orthonitrophenol. Ready? Yeah. Next again, once we are going to Kolb's reaction, Kolb's reaction actually preparation of salicylic acid from where? From phenol. Okay, so actually here in Kolb's reaction, first you are treating with that phenol, you are treating with NaOH, you are actually treating, you are making that, you are keeping that one in what? Alkaline medium, that will be become this phenol react with the base, that will be forming what? Sodium phenoxide. Then you are treating with the carbon dioxide and then you are hydrolyzing, acidifying. That time you are getting what? OH and COH group will be come and attached here in the ortho portion. This is what is called salicylic acid. Salicylic acid. Okay. Salicylic acid. Okay. Salicylic acid. Salicylic acid you are getting. That is what is called what? Kolb's reaction. And similarly, Reimer-Teimer reaction. In Reimer-Teimer reaction, you are getting salicyl aldehyde. So the same phenol you are taking, but you are not at all be taking aqueous NaOH alone. You are taking chloroform. Okay, in mechanism you can check it in Brilliant Qatar YouTube channel. It is there. Okay, here it is actually because through carbene mechanism they are going. Then you are hydrolyzing. That will give you what? You will get what? This one. This is actually orthohydroxy benzaldehyde you will get, salicyl aldehyde you will get. Okay, that is what is called what? Reimer-Teiman reaction. And then preparation of ether. Ether can be prepared according to your situation from alcohol. If you are treating alcohol with H2SO4 at a high temperature means dehydration will take place. From here OH, from here H will take place. Okay, then alkene you will get. But at a less temperature, if you are treating with H2SO4 means nucleophilic substitution will take place. Okay, so see C2H5 OH is there, another C2H5 OH is there. Okay, from here you can see this H will donate electron to this one, so that becomes C2H5O minus. This H plus will come and attach here, so this will become plus. So automatically next step this will take the electron towards it, so it will become C2H5 plus. Now this C2H5 plus will go and substitute here C2H5O, C2H5, like that. Either preparation also possible. Okay, but so according to the situation, the best method for preparing ether is what is called Williamson synthesis. In Williamson synthesis, you are having an haloalkane and sodium alkoxide. Once you are treating them, this sodium as well as halogen, they will form sodium halide and you will get what? An ether. Alkoxy-alkane you will get. That's the reaction. So you have to remember this is an important factor I noted here. See, I noted a very important factor here for preparing ethers containing secondary and tertiary alkyl group. In your ether, if you want a secondary or tertiary alkyl groups, okay, then the alkyl halide used should be primary. Alkyl halide used should be primary and the alkoxide should be secondary or tertiary according to your convenience. For example, I given here, you can see this is CH3C, CH3, ONA. This one actually tertiary carbon. I am taking a tertiary alkoxide and I am treating with a primary haloalkane. This is primary. Okay, that time what will happen? This Na, this Br will go, that will give you NaBr. This CH3 will go and substitute here. So you can see CH3O, C, CH3. That means you are getting an ether. In that ether, a tertiary group is there. Ready? And if you are taking, if the alkoxide used is primary, if you are using alkoxide is primary, for example, NaOCH3 if you are using, just opposite if you take means what will happen now? That elimination will take place. What will take place? Elimination. From here halogen will go, from here hydrogen will go, in between that double bond will come. So what you will get? You will get an alkene. Elimination will take place. That idea you have to keep it in mind. Okay? Yeah. Next again, reaction with HI, hydrogen halide. Okay, hydrogen iodide. Exactly, it is hydrogen iodide. Once you are taking what? Once you are taking an ether and you are treating with HI means this I group always go with the C. You can see here the bond will break and I group will go with the lesser that alkyl group CH3I you will get. Then you will get CH3, CH2, OH. Similarly, if you are taking like this CH3C, CH3, O, CH3, once you are treating that time, here it will break. And always it is purely based on the carbocation mechanism. Herely it will break and it will form this plus. There only which one will go and attach? Iodine will go and attach. But if it is a alkoxybenzene, you are treating with HI. You are treating with HI or HX. Okay, whatever it may be, that one product should be phenol. One product should be phenol and the other product should be what? Other product should be what? RX or else RI. That idea you have to keep it in mind. So dears, next chapter is aldehyde, ketones and carboxylic acid. In this chapter, mainly we have to focus ozonolysis reaction, Rosenman reduction reaction, Stephens reduction, Ettard's reaction, Getterman-Koch reaction, nucleophilic addition reaction. The main highlight of this chapter is nucleophilic addition reaction in carbonyl compounds. Okay, yeah. Next, in reduction itself, two types they are showing: Clemmensen reduction as well as Wolff-Kishner reduction. Okay, then haloform reaction and aldol condensation, then Cannizzaro reaction. Then again with that itself, you have to remember test to distinguish aldehyde ketones, that is Tollens test, Fehling's test and Benedict test. Then again carboxylic acid. In the last portion, we are learning about preparation from dry ice, that means carbon dioxide in solid format, then acidic character of carboxylic acid, then esterification that we already learned, and dehydration reaction, then reaction with ammonia. Then along with that, very important one, HVZ reaction. HVZ reaction. These are the important ideas we have to mainly focus on where this carboxylic acid. Okay. So let's look one by one. First one, ozonolysis. You know the idea. You are having one alkene. That alkene you are treating with ozone. That will give ozonide. Which on treatment with zinc and water, it will give you aldehyde or ketone. You will get the answer easily. You can simply do it like this. CH3, CH double bond CH2. If you are conducting this one, ozonolysis means answer you can easily find it out. Breaking this double bond. Here you put one O, here you put one O. Answer is CH3CHO, CH2O. That means ethanol as well as methanol. Like that you can find out. Whatever the question they are giving. Okay, CH3, CH, okay, CH2, CH, CH, C. You can, whatever the question, okay, whatever the question they are giving, C, here CH2, here CH2, okay, here CH3, and here C double bond CH, single bond CH3. This one on ozonolysis. Double bond you break, here oxygen you put, here oxygen you put. That will be the answer. Idea clear? Ready? So that is what is ozonolysis, that you know idea. Next one, Rosenman reduction. Rosenman reduction means you are preparing an aldehyde from an acid chloride. Acid chloride by reduction. Reduction means in presence of hydrogen, and hydrogen we usually used to store in palladium. But then what's the role of this BaSO4? BaSO4 is used as what? Poison there, because if BaSO4 is not there means this RCHO again will reduce it to what? Alcohol. To stop at aldehyde, we need what? BaSO4. Anyhow, that reduction, acid chloride in presence of hydrogen. Okay, what we are getting? Aldehyde we are getting. That is what is called what? Rosenman reduction. Next again, here Stephens reduction. From nitrile compounds. Nitrile compound, how we will prepare what? Aldehyde. That is what is only Stephens is explaining. What is the idea? SnCl2 you are treating with HCl. Then you are hydrolyzing. You will get what? RCHO. Okay. Keep it in the idea there. Next again, Ettard reduction. Ettard reaction. Here, see, you are having a methyl benzene. That is toluene is there. You are treating with a chromium compound. That is chromyl chloride you are treating in presence of CS2. You are getting a chromium complex you are getting. Then which on hydrolysis you are getting? What? Benzaldehyde. So benzaldehyde preparation, that one. Again, next one, Getterman-Koch reaction. You are having benzene. See, benzene. That from that you are preparing what? Benzaldehyde. Benzaldehyde you are preparing. So here CO is extra. Other than in benzene, you are adding carbon monoxide and HCl in presence of anhydrous AlCl3 or copper Cl. Okay, see, cuprous chloride you can take. So that you will get what? Benzaldehyde. Reactions you hear now? Yeah. We are going through that one. Again, nucleophilic addition reaction. This is a very important reaction of what? Our aldehyde and ketone. Here you can see a carbonyl compound is there. Whenever a nucleophile is coming, that time this oxygen will take its electron because it is highly electronegative. So that time this carbon become positive. So nucleophile will come and add to that carbon. That step is a slow step. Here it is initially planar. C double bond O. Like this means it is sp2 hybridized planar. Whenever this nucleophile is coming and attaching on that one, that will be become what? Tetrahedral intermediate. Okay, tetrahedral intermediate. That's a slow step. That's a right determining step. That time you are getting oxygen minus here. Next step, H plus will be come and added there. You will get additional product. So this is what is called what? Nucleophilic addition reaction. So many nucleophilic addition reaction we have to learn. In that more easily the reaction, nucleophilic addition will take place in the case of what? Formaldehyde, then ethanol, then only ketone. Why? Because in the case of formaldehyde, once you are taking C, here it is H, here also H. And if it is any other aldehyde means, Any other aldehyde means this will take the electron towards here. So this R group is electron donating group. Automatically the positive charge on this carbon will be reduced by this alkyl group. If two alkyl groups are there in the case of ketone, along with that carbonyl carbon, automatically the positive charge on carbon will be decreases. So the nucleophile addition will be decreases. It will be become slow. As well as whenever it is a ketone means, in the case of ketone, not only the electronic reason, steric reason also there. Two alkyl groups are there. So whenever the incoming nucleophile, it will resist the nucleophile to attach on this carbon. That's also another problem. So that's why formaldehyde is more reactive towards the nucleophilic addition reaction than ethanol, than any other aldehyde, than ketone. Ketones are very less reactive. Okay, yeah. Then again, different types of nucleophilic addition reaction you learned. If you are adding HCN, we will get what? Cyanohydrin. If you are adding NaHSO3 bisulfate addition compound, that also you learned. That's actually used for the purification of what? Aldehyde. Okay, then if you are adding NH2OH, hydroxylamine, you will get oxime. If you are adding hydrazine, you will get hydrazone. If you are adding phenylhydrazine, you will get what? Phenylhydrazone. If you are adding semi-carbazide, you will get semi-carbazone. If you are adding 2,4-DNP, you will get 2,4-dinitrophenylhydrazone. Okay, the yellow precipitate you will get, that's used to distinguish of aldehyde, that and all you learned. If you are adding alcohol, you will get hemiacetal. If you are adding, continuously you are adding alcohol, you will get acetal. That all reactions you learned, you have to go through it. Okay, yeah. Next again, reduction reaction. There are mainly two types of reductions are there for carbonyl compound. If you are having carbonyl, that is reduction means you are adding hydrogen. This carbonyl compound become what? Here, instead of this oxygen is going along with hydrogen and it will be forming H2O. Then again 2 more hydrogen is adding. So total 4 hydrogen is participating. You are getting an alkane. That means, see, this is carbonyl compounds. Carbonyl compound from carbonyl compound is converting it to what? An alkane. That can be either done by using Clemmensen or by using Wolff-Kishner reduction. In Clemmensen reduction, zinc amalgam you are using in presence of HCl, and in Wolff-Kishner reduction, you are doing nucleophilic addition reaction with hydrazine. Then in presence of ethylene glycol and heat and hydrolysis, that elimination will take place. Then you will get what? Alkane you will get. So here in both cases, here you can see, if I am taking this one, CH3, CO, this one. If I am treating with this one, zinc amalgam means this O will go, instead of that H2 will come. So CH3, CH2, CH3, this one. So I am getting propana. If it is propanone, I will get what? Propane. Butanone, butane. Butanol, butane. That's the idea. Clear? Ready? That C double bond group will become CH2 group. That's it. Okay? Yeah. That's the idea. Next again, haloform reaction. It's a very, very important reaction. It's a very, very important reaction. You have to remember, in your compound, a terminal methyl group should be there. That should be attached with a carbon. That should contain any halogen. Or else terminal methyl group is there. That should attach with a carbon. That contain OH. Or else terminal methyl group will be there. That attached with a carbon. That should be attached with a double bond O. That means either aldehyde or ketone. Listen to me, aldehyde or ketone. Once you are treating this one with a sodium hypohalate, especially we are taking iodoform means NaOI. Sodium hypoiodide, that means NaOH plus I2. You can take like that, NaOI. Once you are treating means this portion, this terminal methyl group, that will form what? That will form CHI3, iodoform. Yellow precipitate of iodoform will produce. If it is chlorine means chloroform will produce. Anyhow, the most famous one is iodoform test because it will give a yellow precipitate. We can easily identify that the given compound contain what? Terminal methyl group containing a carbon that attached with a halogen, or a terminal methyl group attached with a carbon that containing OH. Terminal methyl group attached with a carbon that contain carbonyl compounds. That can give. That only I wrote here. You can see RC double bond OC3. Here terminal methyl group is there. Okay, that is attached with the what? That is attached with the C double bond O. Here once you are treating with the NaOX, this CH3, this portion will become what? CHX3, haloform. And the remaining portion will be oxidized. That will become RCOONA. This is what is called haloform reaction. Clear? Ready? Next one, again we have to look about aldol condensation. This is also very important reaction. This aldol condensation reaction is given by the aldehyde or ketone that contain alpha hydrogen. Okay, that contain alpha hydrogen only will give what? Aldol condensation. See, here we took the example that CH3CHO. CH3CHO we took. You can see CH3, C double bond O, H. This is CH3CHO that I am treating with one more other molecule of what? CH3CHO that I am writing like HCH2CHO. HCH2CHO. This is your functional group. That functional group attached carbon is called what? Alpha carbon that contain alpha hydrogen. Once you are treating with dilute NaOH, see, dilute alkali, what will happen? This oxygen will take the electron towards it. So normally you know that will be become CH3, CO minus. This will be become plus. Here H. So here this alpha hydrogen is actually H plus. It can leave us H plus. Okay, acidic hydrogen that will donate its electron to CH2. That becomes CH2 minus and CHO. This become H plus. That H plus will go and attach with O. This CH2 CHO will go and attach with the carbon. That product only we wrote here. You can see CH3. Okay, along with the CH, this one CH is there. Along with here that H comes. Then the remaining group comes on with attached with the CH2 CHO. This is an aldol. Why? So you can see 1, 2, 3, 4. 3 hydroxybutanalities. Okay, 3 hydroxybutanal. See again, once you are heating this one, this is functional group, main functional group. That attached carbon is alpha carbon. Here that attached carbon is beta. So beta hydroxyaldehyde is called aldol. From that, once you are heating that one, from beta OH will go, from alpha H will go. In between alpha and beta, double bond will come. That is what is called water molecule is eliminating. That is what is called what? Aldol condensation. That idea you know how to write it. Everything you know. Okay, yeah. But if in your aldehyde or ketone, if alpha hydrogen is not there, then that will give you what? Cannizzaro reaction. So example, if I am taking methanol. In methanol, there is no alpha hydrogen. Once you are treating with the concentrated NaOH, one molecule of methanol will be oxidized to HCOONA, sodium formate. So this is actually oxidation is taking place here. And here this become alcohol. This aldehyde molecule become alcohol, means that is reduction is taking place here. So same molecule undergo oxidation as well as reduction. That is none other than, this is actually what? This is disproportionation reaction. That is actually Cannizzaro reaction. Who will give the Cannizzaro reaction? The molecules that does not have alpha hydrogen, like methanol as well as benzaldehyde, etc. Ready? Yeah. Next again, here you have to remember about acidity of carboxylic acid. We know the carboxylic acids are acidic in nature because that C double bond OH group is there. This H they can remove, and if that C double bond OH group is attaching with a electron withdrawing group like halogen, NO2, etc. That time what will happen? This group will try to withdraw that electron towards it. Automatically that will be compensated from here. So this O will be compensated from this H. This H can be easily removable. That become more polar, easily removable. So electron withdrawing group increases the acidic strength. Okay. Similarly, if it is a electron donating group like methyl group, what will happen? They will donate the electron. Automatically that will be compensated here. So this oxygen become less electronegative. That become less polar. That H won't leave easily. So automatically its acidic strength what? Decreases. That idea also you have to keep it in mind. Ready? Next again, esterification. We already went through this one. Acid, carboxylic acid as well as alcohol. Once you are reacting, you will get what? An ether. You will get an ester. That idea we already explained. Next again, the HVZ reaction, the last reaction, the very important reaction. You are having a carboxylic acid. Once you are treating with the halogen, okay, chlorine as well as bromine in presence of red phosphorus and H3O plus. I mean, that is acid hydrolysis. Once you are doing, you will get a alpha substituted, alpha halogenated carboxylic acid. You will get this is functional group. That attached carbon is alpha carbon. There, instead of one hydrogen, one halogen will be substituted. So alpha halogenated carboxylic acid you will get. What's the speciality of this reaction? This reaction is called Helmholtz-Zelinsky reaction. If this reaction takes place, means we know how to replace this halogen by normal substitution nucleophilic reaction. From here we can make different compounds. Okay, if you are treating this one with KNO2, here NO2 will come. If you are treating this one with AgNO2, ONO will come. Like that. Whatever the compound you want, here you can conduct what? Nucleophilic substitution reaction. So that's very important. These are the important ideas in aldehyde, ketone, carboxylic acid. So you have to go through it. Entire concepts you have to go through it whenever you are solving the problems. Whenever you are feeling difficulty, you just go back to the theory and you just try to learn it. And if you are feeling any difficulties, please comment on the comment box, chat box. We will make the video on that. Okay, don't worry. We will be there along with you. The same word I am telling again in the fourth video also. We will be there along with you. The Brilliant Qatar is there along with you. Okay, don't worry guys. So go and write the exam with more happiness, with a happy vibe. Go and write, and with confidently go and write the examination. We are going to crack it guys. Okay, see you in the next video. Thank you so much.